Okay, kids, even though it's Hurricane Sandy Day, we got to keep moving on with our study of integers. We've done adding, subtracting, multiplying, and today we are going to divide integers. D-I-V-I-D-E, integers. If anybody sat back to think about it, I'm sure you could figure out exactly what the rule is, because it is, after all, related to multiplication. For example, if I know that 3 times 2 is 6, then clearly 6 divided by 2 is equal to 3. By the same token, then, I can figure out if negative 3 times 2 is equal to 6, negative 6, then negative 6 divided by 2 must equal negative 3. If negative 3 times negative 2 is positive 6, then 6 divided by negative 2 is equal to negative 3. And you can also, the final one would be if 3 times negative 2 is negative 6, then negative 6 divided by negative 2 equals positive 3. From this example, you can see that when the signs are the same, you get a positive. When the signs are the same, you get a positive answer. When the signs are different, as they are in these two, you get a negative answer. Basically, what that means is that our rules for dividing are exactly the same as when we multiply two numbers at a time. If I have same signs, they give me a positive. If I have different signs, they equal a negative. Now, one of the things that you should keep in mind is that almost always in algebra, we use the fraction bar to represent division. So if you see a problem like this, it's really the same thing. It's just negative 18 divided by 3. Since 18 divided by 3 is 6, and we have different signs, or else you could also count the negative signs and have an odd number, which would always be 1, equal a negative and an even a positive. But anyway, they're going to look like, the problems are going to often look like this with a fraction bar. You simply divide, as you would with positive numbers, and then if they have different signs, it will be a negative. If they have the same signs, it will be a positive. So negative 9 divided by negative 3 is, 9 divided by 3 is 3. Same signs give a positive answer. I honestly can't remember exactly what all the problems on that worksheet look like, but I will say that all of the other conventions that we've been studying, whether it is the distributive property, or GREMDAS, or evaluating, are all going to be in place just the same as you've learned them if there are problems that involve those. But you should try to do that sheet, just keeping in mind this specific rule. I do want to go over an example from the previous night's homework, because I know somebody might be confused. So let's just talk about, what if I have 2x minus 5 times 3x minus 4 plus 8, for example. 2x and 8 are not involved in the getting rid of parentheses part. Now, what I want to do is I want to distribute this. Remember, the sign in front of the number is the sign of the number. That's why if we have minus a negative, we want to do the slash and dash first, because then this will always be true. Other than that, you can just call this number right here, negative 5. So we say negative 5 times positive 3x is negative 15x. Negative 5 times negative 4 is positive 20. And this sign here is negative because negative 5 times positive 3 is negative, so it just makes this sign in front minus. Negative 5 times negative 4 is positive 20, so it makes that sign in front positive or plus. When we're done, we simply combine the like terms. Remember that I want a box and I want to include the sign in front of the number. So I'm combining positive 2x and negative 15x, and that gives me negative 13x. And then I'm combining positive 20 and positive 8, and that gives me positive 28. Now, at the end of the problem, it will say, so evaluate that if, for example, x equals, let's just make it kind of easy, x is negative 2. So, as always with evaluation, I show replacement. Negative 13 times negative 2 plus 28. Negative 13 times negative 2 is positive 26. And positive 26 plus positive 28, 28 is 54. One thing that may have not been made clear enough to you is what to do in a case that there are a couple problems like. If, for example, it says 3 minus, and then in parentheses, 2x plus 4, plus 6x. Notice we don't have any number in front of the parentheses, so there's nothing, it looks like there's nothing I can distribute. Well, I'm still going to go at this the same way. I'm going to bring down the numbers that don't have anything to do with the distributive property. And since multiplying by 1 doesn't change the value, if there's no number there, what you can do is put a negative 1. Now you're set to go. Negative 1 times positive 2x is negative, so minus 2x. Negative 1 times positive 4 is negative, or minus 4. When I combine my like terms, I've got negative 2x that I'm putting together with positive 6x, which is 4x. And then positive 3 I'm putting together with negative 4, which gives me negative 1. So let's say, and then it's if x equals negative 5, so 4 times negative 5 minus 1 is negative 20 minus 1. Now this is a kind of problem that sometimes still confuses people. You can either think of it like boxing, because you're putting together negative 20 and negative 1, which equals negative 21. Or if it makes it easier for you, you can always say subtraction is the same as adding the opposite, and do it like that. So good luck, and I'll see you in school tomorrow.